Hello, welcome to Saving Grace Homeschool. My name is Leanne, and today we will be focusing on compounds. The learning objective is to understand the difference between elements, compounds, and mixtures. The success criteria is to identify the number of atoms and elements in a compound, to compare the properties of elements and compounds, as well as to classify substances as elements, compounds, and mixtures. Here you have sodium and here you have chlorine. Sodium, as you can see, it's silver and it is a metal. It is very soft, so you can actually cut it with a knife, but it is very reactive and it reacts violently with water. If you throw too much of sodium in water, you'll actually see flames start to be produced. Then you have chlorine. It is a poisonous yellow-green gas with a strong smell. And it was used as a chemical weapon in the First World War because of its poisonous. Right, so you can see very, very different properties. This one is, you can see it's both violent. I mean, this one with water, it forms flames. This one, it's poisonous. But if you go and combine these elements, you will get sodium chloride, which is salt. Just the normal salt that you can find in the kitchen that you use to your food. So you see the properties of your once the elements combined, it forms completely different properties than its starting materials. So you can say the properties of the compound. So a compound is when you have two or more elements reacting together. So you had sodium and you had chlorine reacting together to form sodium chloride, where sodium chloride is now a compound. And the properties of this compound was very different to the properties of the original elements. So a compound is a substance formed when two or more different elements are chemically bonded together. We now have iron and we have sulfur. Iron, okay, yeah, it seems black, but it's actually dark gray particles, and they are attracted to a magnet. You have sulfur, which is a yellow powder, and it is not attracted to a magnet. So the one is magnetic and sulfur is non-magnetic. If you go and mix the two together, they won't react under normal conditions. So if you add iron to sulfur, you'll form a mixture. And in a mixture, you can see that each one's little, you can pick up the sulfur and the iron over here. So you can define a mixture as elements, well, when two substances are not chemically joined together. So you mix the two substances, but they don't chemically join. Like iron and you have sulfur, you'll then form a mixture where you can see the individual sulfur particles and iron particles. So to summarize now, the different substances are not chemically joined together. You can vary the amount of each substance. So you can add more sulfur, less sulfur, it doesn't matter. You will still have a mixture at the end. Each substance keeps its own properties. So if you take this mixture, remember iron is magnetic. So if you take a magnet and go hold it above this mixture, all the iron will be attracted to the magnet and the sulfur will remain behind. So that is a way to separate those two elements from each other. So in other words, they can be easily separated. That was looking at iron and sulfur, mixing them under normal conditions, so room temperature, no heat being applied or anything else. But if you go now and you put your iron and your sulfur in a test tube and you heat it up, they then chemically combine to form iron sulfide. So by applying heat, you have now created a compound. And remember, a compound, that is when two substances chemically combine, and the properties of the compound are different to the properties of the original elements. So you'll have that once you heat it up, you'll form a solid black lump. And if you place a magnet here by this solid, you won't be able to separate the iron from the sulfur anymore, because this, which is iron sulfide, is no longer magnetic. So iron has lost its magnetism. When the heat was applied, a compound was formed because now the elements chemically join together. So looking over here, you get your iron, you have your sulfur, then they have now formed iron sulfide. So the atoms are combined together. And with a compound, you can't vary the amount of each element like you were able to do with a mixture. Remember, with a mixture, you could add as much iron and sulfur as you wanted, but when it comes to a compound, there will always be equal amounts of iron and sulfur. Also, the the compound, so iron sulfide, will have different properties from the elements that it's made up from. So it'll have different properties from iron and from sulfur. And the elements can only be separated using chemical reactions. So with a compound, it needed that heat to be able to form a compound. And now to separate it, you need chemical reactions. When you compare this to a mixture with the iron and sulfur, you were able to use a magnet to separate the iron from the sulfur. But now you need a chemical reaction when it comes to a compound. All right, so for a mixture, you have an element and an element, and then they just mix together without chemically combining. So you still got your iron and you still have your sulfur. Then when it comes to a compound, you have your iron, your sulfur, and now they form a compound. So they form iron sulfide. Look, iron and sulfur, iron sulfur, sulfide. So yeah, they are still separated. We will now be sorting the cards into three piles, whether it's an element, a compound, or a mixture. So if you want, you can pause the recording over here and try it out yourself. I will be going over the answers now. Okay, so over here, this is just oxygen elements. So this will be an element. This is just neon, so that's an element. This is a compound because the oxygen and the hydrogen have actually chemically combined. So this will be a compound. The carbon and the oxygen have combined to form carbon dioxide. So this will also be a compound. Over here, you got sodium chloride. So you got your sodium and your chlorine. They've chemically reacted, so this will be a compound. Over here, you got some oxygen, you've got some nitrogen, some carbon dioxide, and they haven't formed one type of compound. So this will be a mixture. Over here, this is just gold, so that will be an element. Over here, you have carbon and hydrogen, so this would be then a compound. And over here, you see there's various different, you got water, you got sodium, a bit of chloride, and they haven't chemically combined. So this will be a mixture. And then once again, this one will be a mixture. So a mixture, that is when you have a substance consisting of two or more substances. And the key part is not chemically combined together. So you have just mixed them. Here is the experiment that I've spoken to previously, where you can use a magnet to separate the iron from the iron and sulfur mixture, and then only sulfur will remain. So if you've mixed it previously, you can use a magnet and then all that iron parts will come out. Okay, so I've already given the answers, but let's just recap for this one. The elements, let me just get all the answers. So the elements, you see, it's only of with one type of element there. So this is just oxygen. Doesn't matter how many oxygens there are, there's only oxygens present, so it is an element. Yeah, there's only neon present, so it's an element. Yeah, there's only gold present. A compound is when, even though you got many of them, it is when you have the same amount. So you got one oxygen, two hydrogens, one oxygen, two hydrogens, and so forth. This is water. This is carbon dioxide. You see they've chemically combined and they are now together. Yeah, it's also they've chemically combined. So the sodiums are in between your chlorines, same like your chlorines are in between your sodiums. You call this a lattice, meaning they have now, it's a regular repeating unit. And yeah, this is of organic molecules. So you got your carbons all around and your hydrogens. You see, now when you look at the mixture, you got a bit of oxygen, carbon dioxide, nitrogen, and they aren't forming one compound. They're everywhere. Same like, yeah, it is everywhere. And yeah, as well, got a bit of neon, got a bit of hydrogen, but the neon hasn't reacted with the hydrogen. All right, now you can have chemical symbols for all your elements. For iron, it is Fe, and for sulfur, it is S. When you begin the name of an element, it starts with a capital letter. If you add an additional letter, it'll be a lower case. So iron, Fe, and you see sulfur, it's a new element, so it starts with an S. When you combine them, it is FeS. So looking at this, you are able to tell every time there's a new capital letter, that shows that it is a new element. The chemical symbol for carbon is C and for oxygen is O. And this is now carbon dioxide. Carbon dioxide is made up of one atom of carbon and two atoms of oxygen. So when looking at this, you can see there is one carbon, and then when you have a subscript at the bottom, that shows how many atoms there are. So when you leave out the one, just like you do in math and algebra, you leave out the one, and then you got the two. Okay, so the 2 is written as a subscript, so this means it's smaller and it's written below the line. The number always comes after the atom it refers to, and that tells us how many atoms of that element are present in the compound. If there are no numbers, then there's only one atom of that element present. So for looking at water, O is for oxygen, H is for hydrogen. You can see that there are 2 hydrogens and 1 oxygen. And that will be the formula H2O. Okay, now we're going to be modeling molecules. Each person in the class will be given an element symbol. You will represent one atom of the element you are given. On the next slide is a set of molecules. You have 30 seconds to form one of the molecules shown by finding other atoms in the class to bond with. If you cannot make a molecule, you will be out. The remaining players will then have 30 seconds to form a different molecule. If you cannot make a new molecule, you'll be out, and then that's how it continues. So you'll have hydrogen, oxygen, water, methane, and carbon dioxide. And we can build each of the molecules shown below, and it asks which of these molecules are elements and which are compounds. So elements is when you only have that one type of atom present, or one element just means like, yeah, you got just hydrogens, just oxygens. Water, carbon dioxide, and methane will be compounds because you got 2 atoms of hydrogen and 1 oxygen, 1 carbon and 2 oxygens, 1 carbon and 4 hydrogens. So you can see that there are 2 elements. And then once again, yeah, it just shows you when they've modeled it, hydrogen, you see, and oxygen. So that just shows you that there's only hydrogen. Yes, oxygen, and those two barrels or connecting pieces, they are called, well, that shows you that it is double bond, meaning there are two bonds. Yeah, there's only one bond. Yeah, between your oxygen and your two hydrogens, there's also one bond. Yeah, between your carbon dioxide or your carbon and your oxygens forming carbon dioxide, there are two bonds, and like, yeah, it's just one. So this just shows you when there's more than one color, it is a compound. When there's only one color, it is an element. Okay, so we're going to complete the tables to practice interpreting and writing chemical formula. Okay, so for ammonia, NH3, the number of elements, so you go and look at how many letters, like how many capital letters there are. There's nitrogen and there's hydrogen, so there are two elements. Then the atoms, you go and count the subscripts. Nitrogen has an imaginary one there, so it'll be 1 and 3 to give you 4. Over here, it'll be carbon and hydrogen, so your number of elements is 2. Your number of atoms is 1 plus 4, which is 5. Yeah, okay, now be careful. There are only two elements because look at the capitals. There is a N and a C. Na is sodium, Cl is chlorine. So it's only two elements. And atoms is also only two. Over here, you have your calcium, your carbon, and your oxygen. So the number of elements will be 3. Okay, remember, don't look at the lowercase letters, only at the capital letters. And the number of atoms, you got 1 for calcium, 1 for carbon, so that's 2, and 3 for oxygen, so that's 5. Number of elements here, you got hydrogen, sulfur, and oxygen, so it is 3. The number of atoms is 2, 3, and 7 if you add them all together. Number of elements for this one is sodium, which is 1, hydrogen, so that's 2, carbon is 3, and oxygen is 4. Number of atoms, you got 1, 1, 1, and 3, which gives you 6. Okay, number of elements. Okay, sometimes they repeat it. So you're only going to see how many, like for example, there's a carbon here and a carbon there, but that's one element. You have a hydrogen there and a hydrogen there. That's also only one element. Likewise, you have your oxygen and your oxygen. That's only one element. So all in all, you only have 3. You don't go and count 1, 2, 3, 4, 5, 6. If the letter repeats itself, then you omit the last letter. And the number of atoms, you go and count 1 plus 3 plus 1 plus 1 plus 1 plus 1 to get 8. All right, we are now given the name of the compound, the number of atoms, and you have to give the formula. So it's 1 hydrogen atom and 1 atom of chlorine. So it's just HCl. 1 atom of hydrogen, 1 atom of your chlorine. Now you have 2 atoms of carbon and 4 atoms of hydrogen. So you see you got 2 of your carbon and 4 of your hydrogen. Then you get aluminium oxide. You got 2 atoms of aluminium, 3 atoms of oxygen. Nitric acid is this. You got 1 atom of hydrogen, 1 atom of nitrogen, and 3 atoms of oxygen. Sodium hydroxide, you have 1 atom of sodium, 1 atom of oxygen, and 1 atom of hydrogen. Glucose is like this. You got 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Okay, here is now a activity where they give you a compound and a mixture column, and you have to go and say whether these are compounds or mixtures. So the first one, these are all the properties. The first one is the substance has different properties to the element it is made from. That will be, okay, I'm going to color code it. So when it's a compound, it'll be blue. And when it is a mixture, it'll be red. Okay, so the first one. The substance has different properties to the elements it is made from. That is a compound. Each substance can be easily separated. That is a mixture. Remember, to separate a compound, it needs to be done by chemical means. You cannot vary the amount of each element. That is a compound. With a mixture, you can add as much as you want to for each one. Each substance keeps its own properties. That is a mixture. And you see, like the opposite here was for a compound, the substance has different properties to the element it is made from. The next one, the elements can only be separated using chemical means. That is a compound. Remember, with a mixture, you could use a magnet to separate the iron from the sulfur. Over here, the different elements are chemically joined together. That is a compound. Anything that involves chemically, that key word, that is a compound. Then if it doesn't have that word, so the different substances are not chemically joined together, that will then be a mixture. And the last one, you can vary the amount of each substance. That is also a mixture. In this table, it is the same as this exercise. So I have already answered it for you. And then that is all for the differences between elements, compounds, and mixtures. Bye, everybody.